welcome back to the Platinum Global Solutions event. We're discussing for the annual Global Brand Protection and IT Security Summit for 2024. We've had the pleasure of having many keynote speakers already today presenting. We just listened to Floyd Pernish and we posed him a particular question. And we are going to be moving on now to Mr. René Cluis, who joined Philips in March of 2022 and has a focus on worldwide regulations.
Yeah, correct. And in that context, I'm gonna talk a little bit about one of the regulations sped up the necessity to have software bill of materials and what are the financial consequences for that. So I don't know if you want to start me to present already, or do we wait a little bit longer for the people to return from lunch? What's the plan? You look frozen to me, Elliot. I don't know if that's my problem or.
Okay.
I think we missed the
Okay.
beginning.
Okay. I guess it's
Okay, I can
internet
hear other
issue.
people, so.
Yeah. So I guess let's start with your presentation then.
Okay, you were a little bit soft. I'll crank up my volume on my side. So can you repeat?
I said let's start with your presentation.
I will start the presentation.
Yeah.
Then, of course, I have to get the presentation on screen. Beginning.
Oh,
And then, of course, I have to share my screen. Which screen? I think this screen. Share. Can you see my screen?
Oh, yes.
One moment. Of course, somebody's at the door now.
Okay.
Okay. I shoot that guy away. So, yeah, once again, I will continue presenting now. I don't have a view on the chat window, so if you want to have a dialogue, a conversation, a question, just shout out and I will try to answer it as we go.
Oh, okay.
Yeah, so I work at Philips. Most people do know a lot of Philips. But be aware that Philips nowadays is only an MDM, medical device manufacturer. You know us from the light bulbs, you know us from the TVs, might know us from the coffee makers and all kinds of things. That's no longer Philips. Philips is only in the business of making medical devices like CT scanners, MRI scanners, and other stuff you find in hospitals and in medical care environments. I work at Group Security, which is quite a large group within Philips. Within that, I focus on product security and do regulatory and standards. And not only about what the regulatory and standards are coming our way, but also in the sense of, and how do we deal with it and how do you implement that? So in that context, I'm focusing on a very narrow, very specific subpart, which is called SBOM, which stands for Software Bill of Materials, due to recent events in the supply chain security world, like the Log4j incident and solar burst from SolarWinds and a couple of other incidents. It became painfully clear that there is not a good visibility and transparency about which software modules are being used in products which are on the market. And for instance, with the Log4j, there was a large panicking which lasted a few days because most of the companies were not able to pinpoint if they did or did not use Log4j. And if they did, where and which part of the software Log4j was used. For that, the Executive Order 14028 was issued in America by Biden and Harris, to speed up the requirements that, listen, if you want to do business with the United States, you have to be able to give us a software bill of material, providing transparency about what software models you are using in the products you want to sell to us. Now, the whole list of ingredients, of course, is not new. It's been around quite a few years, but the whole thing with the supply chain attacks of Log4j and SolarWinds accelerated and became an official requirement in the executive order, which became a regulation because the Food and Drugs Administration will no longer accept registrations of new products without a software bill of material. So never waste a good crisis in that context. And now it is not only in United States with the executive order, but also, for instance, in the European Union with the Cyber Resilience Act, it is demanded that you, upon request, should be able to give an inventory of the software elements you use in the form of a software bill of material. You will see that happened, and the executive order was announced in 2021. It took a little while before all the departments of the US government were able to formally describe what was needed and stuff like that. And you see that with the NIST guidance and the FDA itself and going on, and the executive order contains a couple of things. It is not only about the software bill of materials, but also something about which they call secure software development attestation. So both are basically the two sides of the same coin. The software bill of material is about show me what's in your software. And the secure software development framework attestation is more about show us that you developed that software in a secure manner. It became a law, which is good for America, because basically it's now for the US government. If you want to sell to the US government and you don't have an SBOM, they won't buy it for you. And money is, of course, always a good motivator to take care of business. Not only the US is working on it, I already said that European Union is working on it as well. A lot of trade organizations also strongly suggest that you do it. And in the medical world, that of course is, for instance, the IMRDF and MDIC, who are trade organizations who push the use of SBOM going forward very much. Now, the SBOM itself is part of what we call application security testing. And you have traditionally the static, dynamic, and interactive application software testing. New to that for a few years is the SCA, the software composition analysis, where SBOM is a part of. You have a couple of other testings as well, like fuzzy logic and stuff like that. My point is that both, and we saw that in previous presentations as well, it's important to test during the development, because then the feedback cycle is short, it costs relatively less compared to testing and remediation vulnerabilities in applications which are already on the market and in devices. I included, and the presentation will be made available, some links where you can find additional information about topics. Now, if I have to explain what a software bill of material is for layman's, it's quite an effective story to compare it to in the food world, where you have to have labels with the product on it name, but also the content of that product, what is in the jar. And you all are familiar with those things, like how much fat and carbohydrates and fibers it contains. And you can say that the software bill of material is quite equivalent to that, but then for a software-based application. And you see here that this is an SPDIC SBOM format example. SPDX is a kind of formatting language being used because this also needs to be machine parsable, those SBOM files, to be able to scale up and repeatedly check the contents. So in your mind, you can pretty much compare that to a label with content as we are used to if we buy food and drinks and stuff like that. Let's try to get to the next one. Already called the IMDRF, the International Medical Device Regulatory Forum, which from an early age already is a supporter to use SBOMs, and I will click through this animated slide to explain a little bit how an SBOM comes to be. During a development, design, code, build, test phase in your CI/CD pipeline or your traditional development environment, you will collect all kinds of information about I am using software which I bought from commercial vendors, and that they will provide me with a third-party SBOM. Specification, build outputs. Outputs I do by running software composition analysis tools. And they usually always contain commercial off-the-shelf software, but they can also, of course, contain firmware, embedded software, programmable logic controllers, operating system, and open source components and libraries and third-party lab. So that whole collection of all the software you use to compile your end product solution will be part of the SBOM content, which will be generated and released for stakeholders. And then, of course, you could say that is a snapshot which is taken at a certain point in time. I bring it into production, I take a snapshot. These are all the elements which are part of the software in the software BOM of material, but then you of course have to maintain it, because once it goes into the market, new vulnerabilities will emerge. And it's the question now from those new vulnerabilities, do they have any impact on my solution already in the field? So we have to do management. If there is a match that the vulnerability might or might not impact the solution there is, you have to do more research and notify customers. And you do that with something it's called Vulnerability Information Exchange, which is VEX stands for Vulnerability Exploitability Exchange. Basically an overview of those vulnerabilities which are applicable to your solution you have at home, and what has been done about it. Has it been mitigated? Has it been fixed? Is it patched? Is it not reachable? So that together with the software bill of material and such a VEX document, or vulnerability analysis document as I prefer to call it, you have a good insight about the current state of your vulnerability. There's of course a good feedback loop should be applied, that the lessons learned at the end of that process are fed back into the beginning of a new development cycle for a new version or even a new product that you can use whitelist and blacklist and licenses over you and so on. That information is all made available internal because there are two big aspects of software bill of material, an internal and an external part, and we come back to that later to show more in detail where the expected benefits can be found. Now, this is one development environment. Of course, you can have multiple development environments which in parallel do basically the same, as long as they generate the agreed upon standard form for an SBOM which you can use internally, because there are many different development environments. There are environments who work with open source community software. There are environments which work with embedded Linux, with real-time operating systems environments. So it's not one size fits all, and there's not one silver bullet. But if those development environments do work accordingly to a process or processes that they generate an SBOM in a certain format with a certain content, we don't care too much about the specific different environments. Of those master bombs, you can create sub SBOMs too, or compounded SBOMs as well. Now, if you look at what should be in an SBOM, there is a well-defined list of minimum fields which are adhered to, but it has a couple of characteristics. It should, as already said, human readable and computer parsable, in the sense that you have to, with scripts and other application, be able to take the collection SBOMs and put them into an application environment which checks for vulnerabilities, instead of typing all those vulnerabilities and elements in by hand. And for that, the two most used favorite language are SPDX and CycloneDX, which have a certain layout. They are human readable in the sense of that they are no binary files. So you can open them, for instance, in a text editor. So you can read the content. You have to be aware of the format used to make sense of it, but it is human readable and computer parsable. It's also that like I said, at a certain point, just before you release your product in the final build, you make a snapshot of it. That also means that the structure of an SBOM doesn't change in its life cycle, because if you make changes to the product, you will get a new SBOM for that new version of that product. Going forward, it is possible to what we call enrich an SBOM. If more information is becoming available in more detail about the components of the software collection you use, you can add that to the SBOM, because it doesn't change the structure and the dependency. It only gives more information per line item, so to speak. And sometimes it's more valuable to have more information, so you can enrich, as we call it, an SBOM. But the structure never changes. That's what this paragraph about it. You can correct an enrichment if necessary. Furthermore, there's a lot of development still going on about how do we make sure that if I provide an SBOM, it is indeed coming from Philips and not from somewhere else. So non-reduplication. Integrity, hasn't it been changed on the way? Are all the hash values still correct? Those are things which we can address and will address, of course, with cryptographic techniques. The only problem is that the market is not defined a standard how exactly to do it. So there are a couple of developments going there. One of the major problems with SBOMs, and then I will quit the technical details about it, is that everybody should call an apple and not a pear, for instance. So it's very difficult to reach an agreement about how software modules are called. For instance, you have a very popular compression module in public domain, which is called 7-zip. And if you write it 7-zip, it is for computer parser something else than 7-zip or 7_zip. So we are really wrestling, the whole market is wrestling with this unique naming, in the sense that everybody gives the same name to the same software. In a nutshell, because I have to look at the time, I started 10:04, it's 10 after now, so I have 20 or 10 more minutes. An application SBOM is really simple. You have an application which contains of source code, which you developed yourself, source code from open source, binary code from third parties, which is included in SBOM, and this whole is the application SBOM. If you run it on a system, and it's a monolithic system, a standalone PC, you can say application, operating system, firmware, hardware. We have the application SBOM. See the previous slide. We generate or create or have an operating system SBOM and firmware SBOM. That's the platform SBOM, and together they make up the solution SBOM. Becomes a little bit more tricky if you use virtual machines and data centers. Then you have a decoupling of your application and where your application runs. In this example, you can still generate the sub-Lego blocks to come to a total solution block. But if you want to move into the cloud and cloud service providers and into cloud, it becomes a little bit more difficult to get clarity about in what instance in time the total used software components on which you get that service from are composed of. But there is progress with that as well, and a couple of standardization committees are working on that, and we're taking part in that as well. Now we come to the meat of the presentation. I explained a little bit what SBOM was and what the challenges are there. There are drivers for SBOM are easiest one are the external ones. It is demanded by regulatory, the China NMPA, that's the equivalent of the FDA, the Food and Drug Administration in China. The European Union Cyber Resilience Act is demanding it. The United States Executive Order 14028 and the FDA is already in. And we see more and more countries outside the EU and US and China pushing towards that, like Japan already has similar requirements. The trade organizations, I already mentioned the IMDRF, the HISAC, the Health ISAC is also pushing projects to stimulate the uses of transparency in the form of SBOM, and same the Medical Device Innovation Consortium as well, the MDIC. Our competitors like Siemens Healthcare, GE Healthcare, or Medtronic are also doing it because it's a very strong pull from the market that customers demand transparency. So those are the external things. It's a must-have. Do I hear a question?
Yeah, Rene, looking at the time, someone's asked a question specifically about what the cost benefits are or the considerations for
I'm coming to
cost
that.
benefits. Yeah.
So give me one. It's the next slide, I think. The internal are mostly driven by quality assurance aspects. If you take care of your visibility, of your transparency, of your content, then you can also optimize it and things like that. That's a cost benefit. And for time's sake, I will skip this. We have 3 phases: generate, manage, and distribute. This is the meat of the thing about the cost benefits. I already said
qualitative and both quantitative, I see, yeah.
Yeah, it's a must do, because if you don't do it, you cannot sell your products to the American market. So, okay. Yeah. Internal aspects, it enhances your quality of your software, meaning if you do it in an early stage, you can detect vulnerabilities in an early stage. You can correct them for a lower price than afterwards, stuff like that. That's vulnerability management. You have licenses management. We want to know, of course, which licenses we use where we have to pay for and which licenses our customers have. That is a better overview you get as well. It's a bit tricky because if we look at the 20 business units we have, what do you do if you see that they use 7 libraries which are functionality speaking very equivalent? Are you trying to standardize them on 1 library instead of 7 libraries to save a lot of fees and stuff like that? The final thing is a feedback. These are all qualitative aspects. Everybody expects and understands that if you do good transparency, you will get better quality software. But how to quantify it, how to put a dollar value on it, that's a bit difficult. We looked at peers and our own way of working, and we can make very generic statements that if you have many products, it can save you in man hours up to $100,000 per year if you use SBOM, versus if you don't have the usage of SBOMs available, because then you have to do much more manual work, much research work, instead of being automated in that sense. So
automation, just to ask you again, because you said just before we finished and took our break, we had the lovely Floyd who mentioned about the components of an effective data-driven reporting system. for
Yep.
cybersecurity and privacy, and that was something that you wanted to touch upon yourself. What
Yeah,
are the
we
essential components, do you
we
think?
are in the process of when we go forward to do more keeping track of key point indicators about how much
Mhm.
time is saved, how many vulnerabilities do we catch before it goes into the production, how much
Mhm.
decrease do we see from feedback from customers. And the trick there is, of course, to put a dollar value on that as well, where that is something surprisingly difficult to do, but it is
Yeah.
something we want to go on the executive dashboard, show that. And the previous slide where I have 50 KPIs, no, we will have like 3 or 4 KPIs about time saved, vulnerabilities catched, and overall longevity of time in the field, so to speak.
A dashboard as
In
such.
conclusion, I want to close with this slide that it's the most important question, of course, is that if our equipment is being used in the field and people hear about a new vulnerability, we should be able to say very quickly, give them answers to the question, am I at risk? Because if we learn something from the Log4j and other things, is you cannot live in, if it takes weeks to find out if you have exposure to a certain vulnerability, that's no longer accepted. And with that, that's the presentation.
Thank you.
I will see if I can find the Q&A answer. Okay, what is the essential components of effective data-driven reporting? That's the last thing. What is the
Yeah.
cost benefit consumers have or when adopting SBOM? Well, I touched upon that, of course.
You did indeed.
It is said before, you cannot manage what you don't see or cannot see, stuff like that. If you make it visible in that sense that you are transparent about which software modules you have, you can do the vulnerability mapping to that software component, and you can mitigate it or remediate it much quicker and better, fewer, hopefully, than if you don't have the SBOMs.
Yeah. Assurances are required, metrics need to be monitored, and risk management is a necessity.
And the trick is to automate it and integrate it as much as possible going forward. That one of the questions was, can AI take away jobs? Well, it can take away the boring, repetitive jobs with machine learning and AI. And if you have an integrated, automated chain like we are working at Philips, from development, managing and monitoring and publishing, to get rid of the most noise.
Yeah.
The same with security management in the SIEM, of course.
And talking of the technology, obviously working for Huawei as a technology.
Sorry? Seem to be frozen again. I see Agnes moving around, so